Marko Gargenta founded Maracana back in 2001 to help underprivileged youth, minorities, and inner-city kids learn web technologies and get ahead in life. Maracana emerged with the goal of helping people get better at what they do professionally, focused on open-source software training. Marko himself has taught Android for Sony Ericsson, Qualcomm, Ericsson Canada, and many others, and he's a co-founder of the San Francisco Android User Group. Marko's also the author of the book Learning Android from O'Reilly Media, and that's how we know each other. I always try to give the social network connection that explains how I met the speaker. But Marko and I met at an O'Reilly Authors Party at the Web 2.0 Expo, I think, in San Francisco, maybe earlier this year. And he's also the co-chair of Android Open, an O'Reilly conference focused on the Android ecosystem. So Marko's going to speak today about developing for Android applications. Please welcome Marko Gargenta.
Thanks, Christian. Let me just switch this over to this. Cool. Well, thank you for coming here to see this talk. So we're going to talk about Android building blocks as a way of building application, any sort of medium-sized application. The reason why I picked Android building blocks is because I consider this to be sort of a constructs that are specific to Android when it comes to building an application. So just to kind of get a sense of who you guys are, how many of you have experience with Java? All right, so about half or more. What about C, C++? Okay. And what about Android? Anybody wrote anything for Android? So a couple of you. Okay, cool, excellent. Excellent. So it should be interesting for all of you in a way. So just like Christian already said, my background is in Java. I've been doing Android extensively for the last couple of years, doing a lot of training all over the world. And in the meantime, I also published a book, Learning Android. That's the cover of it. I often speak at conferences such as OSCO and IEEE, ACM before, and so on. Android Open is a conference that I'm co-chairing that's going to be in San Francisco in October. That I think is going to be a very valuable resource for anyone involved in the field. So what we're going to talk about today are a couple of things. We're going to talk about the main building blocks, and I kind of handpicked certain things that I consider to be important. We're going to talk about activities, services, intent services, broadcast receivers, content providers, what an application is, system services, and so on. But just to kind of give you a context for all this, just so it's not just something that's abstract. I'm going to show you a little application that I put together. And what I'm showing you here is just an emulator. So everything's running in an emulator, but it's an actual code. It's the same application that runs on a physical device. It's just easier to show this way. And this is basically a little Twitter application, right? So everyone gets what Twitter does. You may not be using it, but you understand how it works. I find this application to be fairly comprehensive. So it touches on many moving parts when it comes to Android. And it's a good example of how different things work and why you would care about them. So what I'm going to do first is I'm going to show you. So this is one screen where I get to update my status. I can say hello from Park, for example. I can click on update. This is attempting to connect online, may or may not actually work out. And it's going to, if it's successful, it's going to post to a server that is adhering to the Twitter protocol. So it's basically doing the same stuff as actual Twitter. We're not using Twitter because Twitter shut us down when we have a lot of people using it at the same time. So in this case, it didn't work. My network is running through a proxy, so there's lots of reasons why it may or may not work. Just to show you another screen where we can see the timeline of my friends, or public timeline in this case, on this server. So basically what we have here are people who are following my book and doing the example application there and basically posting to the same server. So this would be another screen. So just to give you kind of the context for it. So far you've seen two screens in this application. There's also a third one. It's called preferences. And that's where you get to set your username, password, that sort of stuff. Things that are important when it comes to any application. So other than these three screens, we also have certain other components, such as a service that runs in the background, and it attempts to update periodically your timeline and basically get the latest information. So it's a very simple little application that I put together just to illustrate various constructs. So in the context of that application, we're going to start talking about some of these things. By the way, the code for this application and everything else is available on GitHub, and you guys are going to have this presentation later on, so you'll be able to find it. I also have a longer version of this presentation, a 3-hour version that I did at OSCON. So the slides for that are available also at maracana.com, and that's the shortener right there. So for those of you who care, so this one right here. And again, we're going to have this information later on, but it's maracana.com/f/393. That should get you to the right place. So moving forward, we're going to start talking about activities. And activities are basically the components that represent a screen. So we're going to talk a little bit about what an activity is, what the life cycle of the activity looks like, and basically what are some of the main methods in that activity. So in that sample application that I showed you, we had 3 screens, right? So roughly an activity is a screen. So it's one of the main components that you use to assemble an Android application. So you build these things called activities, and they represent a piece of UI at a time. So not just a button, but more of an entire screen. So in our example, we had 3 things. We had a screen where I get to update my status. We had a screen where I can see what my public timeline looks like on Twitter, and I also had a screen where I had the ability to set up some settings such as username and password. So a typical application may have many of these screens. One way to think about them is sort of like in a website you have multiple web pages, but there's usually an entry point, like a home page, a main page. So it would be something like that. Now, what's interesting about activities is that they have a fairly complex life cycle. They're heavily managed by the system. They're considered expensive in terms of resources. So the life cycle for activities is quite involved. It basically involves starting from scratch, loading up an activity, putting it onto the screen. So this is the case when your activity is visible. It's drawn up on the screen. And then at some point, the user is going to flip between screens. It's going to go from one screen to another. So what happens is that activity gets partially gets paused for a moment and really quickly gets stopped. So you basically have many stopped activities at any point in your device. So you could have dozens and dozens of stopped activities. So they're basically living in memory, sitting there in case that they may get called back onto the screen at some future point in time. The reason for this is that this tends to be much cheaper than this startup process. So this is sort of expensive in terms of the resources that are involved in starting up. And as we know, user wants a really quick user experience. So to do that, we keep them essentially cached so that we can bring them up to the screen really quickly, right? So this is much cheaper in terms of the actual execution time. Now, what's interesting also here is that you as a developer don't get to kill your activity. So your activity just gets destroyed by the system at any point in time. So this is where programming for Android is sort of different than programming in a standard Java environment. In a standard Java environment, you start your program and you instantiate objects, you do this, you do that to them. In Android, we're basically programming inside of a container. So you don't get to instantiate a lot of these objects. It's the system that actually instantiates them, and the system basically just calls the callback methods on your objects. So essentially, you are responding to events as opposed to driving what happens, right? We don't get to pick which state our code is in, but we get to say what happens on a transition, right? So if any of you programmed for applets or servlets, it's a very similar conceptual thing. So essentially, we get to say what happens on these transitions from a state to a state, right? What happens on these transitions, but we don't get to say which state we're in per se. The system is going to drive the object into that state. So that's why it's quite different if you're just coming from a regular Java background. Okay. Any questions on this, by the way? Feel free to ask at any point in time. This is one of those things that I keep referring back to quite a bit, and I find that people have various levels of understanding it. It's kind of like peeling an onion, so there's sort of more deeper and deeper to go in terms of why this works the way it works and what to do about that. Yeah. Yeah, so what's happening in the pause state is the question. So the pause state is not a very typical state. It means that your activity is still partially visible. So the case for that would be a dialogue, right? If you had a smaller activity pop up on top of the one down below, that one is still visible, but not in focus, cannot be touched. So because the system is not going to remove that one from memory, it keeps it around in a pause state. But not many activities are in a pause state, so it's not a very, very typical state to stay in. Yeah. So moving forward, so that would be an activity. That's one of the main building blocks, very basic one. Moving forward, what we have are services. So services are also very common components that you use to build an application. So what the service is a piece of code that basically runs in a background, right? So a good example of where you may have a service would be a music application. So if I'm writing an application such as a Pandora, for example, right? I do need a piece of UI where I'm going to pick a song or a station that I want to listen to. So this would be that piece of UI, right? I get to choose the song, I get to say thumbs up, thumbs down. But knowing what we know about activities, you now understand that this piece of UI can disappear at any point in time, right? The system may say, hey, you've been stopped, I need more memory for the one that's in running, and just dispose of that activity. So as such, you do not want to own the playing of the music inside of that code that could be disposed of at any point in time, right? So that's where services come very handy. So we would create something like an audio service that would actually own the playing of the music, right? So you would have a piece of UI, i.e. an activity, that would have the GUI. You would get to press the button, play, and that would start a service, right? You would press another button, you would say stop, and that would stop the service. So this could be disposed of. User doesn't really care, nor knows that got killed, but the music still keeps on playing, right? And then the user may call back the UI, and at that point, use it to stop the service. Okay, so that's one of very common component when building an application. So services have a much simpler life cycle. So they still have a life cycle. It's still true that you never instantiate a service, right? You don't say new service, but rather you just subclass it and implement some callback methods. And those callback methods are things like onCreate, onStart, or onStartCommand, onDestroy, and so on. So it's a much smaller set of methods or callbacks that we have to deal with. But conceptually, it's the same thing. Our service lives inside some kind of container, and that container manages its existence, right? So a typical service would just start and stop, and that's about it. One thing to keep in mind when programming services is that we think a service is something that runs in a background, right? And that's a loaded word, running in a background. To us, it may mean that it's actually running on a separate process or a separate thread altogether. It actually runs on the same process, in the same process on the same thread as your UI. So if you have a service that's doing something substantial, like in my case, pulling tweets from Twitter, you may not want to do it in its own thread because that's going to block the UI thread, right? So the application is going to appear like it's not running, and you're going to get that infamous application not responding, ANR, error message, right? So keep that in mind when programming a service. It's just not visible. It's just a piece of code that doesn't have any UI. It's not really a background task as we would think of it in Unix or some other operating system. So there are tools that allow you to simplify posting on a separate thread, but that you have to worry about that separately, and you have to do that separately. Okay. Any questions on services? Does it make sense to everyone? Yeah. All right, so moving forward, what we have is something called broadcast receivers. So these are other components that we use when it comes as one of the main building blocks. Receivers are basically your publish-subscribe mechanism. So it's a piece of code that I may say, okay, I have a piece of code and I want that piece of code to subscribe to some kind of event, some kind of system event, and I want it to be notified when that event happens, right? So a typical example for that would be an SMS receiver, right? So I may have a piece of code that says, look, I want to receive an SMS message. So I would subscribe to a system and I would say, hey, I want to know when that happens. Now this code is dormant, it doesn't run, it's not taking any CPU or any memory or anything like that. It's simply registered. At some future point in time, when an SMS does arrive, the system generates an event and triggers our piece of code, wakes it up and says, do your thing, that event that you care about happened, right? So it's a classic publish-subscribe sort of pattern in this case. So this is one of the main building blocks that we have in Android. Okay, very useful. And finally, what we have, not finally, but one of the main ones, the bigger ones, is something that called content providers. So content providers are basically a way to share data between various components inside of your application. So a typical application sort of looks like this, right? I draw it as a box, but a typical application is a Linux process on its own that's highly isolated from every other application. So in other words, applications are sandboxed in their own processes with their own UIDs and GIDs and all that good stuff. So one application cannot see another application, cannot see other applications' data, can in no way basically look inside of another application. But every once in a while, you do want to share that data, right? So in that case, content providers provide for that mechanism. It basically allows you to pierce a hole in that security block and expose data. So content provider is a very simple, basically interface that provides for the 4 things you can do to a data. You can insert, update, delete, and query data, right? So that's essentially what it does. We see this in Android quite a bit. For example, contacts use this, right? When you have your address book application and you want to see your people, that is actually 2 separate applications. It's one application that has the GUI, and the other application has the actual data. So what that allows for is you can have multiple address books, maybe a nicer one, right? Like in HTC case, if you have an HTC phone, they have a sexier version of an address book, right? But it talks to the same data store. So you can have multiple applications sharing the data. My Twitter application could share its tweets with some other applications, for instance, right? Media store is another example of a place where we use this. So if I snap a photo with my camera, that photo gets placed into the media store. So it's available to my Gmail and my Facebook and my Twitter, so I can share it. It's also available to my wallpaper, so I can put it on as my background. So a lot of these applications take advantage of content providers. So content providers have a much simpler life cycle. So they basically start and get destroyed as needed. So as we need content, as I need to know what the tweets are available, I would basically just ask for it, and I would query probably the tweets. So you only have the 4 things you can do: insert, update, delete, and query on a content provider. Usually content providers are backed by a database that sits inside of your application, but it doesn't have to be. It could be a cloud-based service as well. Okay, does that make sense? Content providers and the reason for them? Questions on it? No? Okay, so moving forward, so those are the sort of main components that we have to build an app. We have a screen, activities, we have services, we have broadcast receivers and content providers. Now we need a glue. We need a way to basically connect these things together. One type of a glue is something called an intent. An intent is, again, it's one of the Android constructs, and what it represents is an event or a message. It basically says, here's something happened, do something about that. So I'll give you an example of a typical scenario. So for example, I may be in my Gmail application. So this would be my Gmail application, right? And I'm inside of that application and I'm viewing a specific activity. So this application in this case has two activities, right? One is to view the messages, so I can see all the email messages. And then I can click on a specific message, right? So when I click on that specific message, it's going to open up another screen. And that other screen is another activity, right, for viewing a message. Now, I'm reading this message, and inside of it, it says, okay, you know, here's a story on the web about something that just happened, right? So I click on that, and that's going to open up a web view. So that's going to open up yet another application altogether that's going to show me what happened on the screen, on the web, right? So I'm now inside of a web browser application, different app altogether. And I may be reading this story on Slashdot, and I may click, there may be a video link inside of that. So I click on that video link, and that now opens up the YouTube app. So basically, I went through 1, 2, 3 applications as a user on the same device, right? And I went through 1, 2, 3, 4 different screens to view all this, right? So I completed a task. To a user, it doesn't really matter. We're jumping from app to app. But what allowed for this are basically intents. They provide for that messaging between those components. One thing that's kind of cool about intents is that you can have implicit or you can have explicit intents. In other words, you can say, hey, here's a specific screen that I want to open up. So in this case of Gmail, we were very explicit about which screen is going to open up my message for a viewing. But in a case of a web browser, what we did is we just said, hey, just open up this web page with whatever web browser is available. So what that allows for is to have multiple applications compete for the same intent. In other words, it sort of works like on Windows when you installed your Firefox or your Chrome to replace your IE, right? They competed as your default web browser. So Android is sort of unique because you can do that, and you can't do that in some other platforms, namely iOS, for example. So that's sort of a very nice feature of it. You know, one of the early claims was that all apps are created equal in Android, right? So that's what allows for that equality. So one of the other components that we have is something called an application with a capital A, right? So this is basically a component that's holding everything together. So an application essentially keeps all your activities and services and providers and receivers all in a one box, right? So one way to kind of think about it is that if your application is, if your app is like a pizza, then essentially an application with a capital A would be the dough, right? And then you would put any number of activities and services and providers and receivers into it as toppings, right? And that's how you basically assemble your app when it's all said and done. So in terms of an application lifecycle, it's much simpler as well. So you start it, it keeps on running, and at some point it dies. So the idea is the same. You as a developer only get to fill in the blanks. These are the blanks that you can fill in, and the system manages calling of what happens at what point in time, right? So there's also system services. These are applications that are not written by you, but are available for you to tap into as an application developer. So for example, if I want to know what my location is, well, there's a service for that. It's called a location service, right? So these services are available on the system, and you can basically just, as a developer, tap into them. Some sample services would be alarm service, connectivity service to manage what type of a connection you have, a download service for downloading long content, near field communication service, so if you want to tap to pay at Starbucks, for example, power service, so if you want to get notified if the battery is running low, for instance, sensor service for games, for instance, telephony service for making phone calls as such, and Wi-Fi service as well. So there are about a couple of dozen of those services that are available for you at any point in time to tap into. System services best practices are that they tend to be expensive to use. And by expensive, I mean in terms of a battery. So unlike other ecosystems you might have programmed for, like the web, web servers and such, web app service, for mobile, we care about battery life quite a bit. So we don't care about certain other things that you would care, for example, in enterprise computing, but battery life is quite important. Certain things use much more battery than others. So for example, listening to GPS is fairly expensive, right? So if your app or your activity is listening to GPS, you want to turn it on when you really need it, and you want to shut it down when you don't need it. So for instance, remember how an activity, when it's not being used, it's still alive in memory, right? So if I'm inside here and my phone is turned off, I probably don't want to be listening to GPS because it's just going to be draining my battery in the background. So I better remember that life cycle of an activity and shut it down in a proper place, and then turn it back on when the user turns the phone back on, right? So that's why certain things like that are very important when it comes to the mobile experience. So what I'm going to do now, back to that application, the Yamba application. Yamba stands for yet another microblogging app. So that's that Twitter app that I did. In terms of designing that application, I'm just going to kind of walk you through how to design an app in terms of just lines and circles, right? So keeping it free of code, just to kind of conceptually understand the lines and circles. Once you get that, programming it is fairly straightforward. Especially, most of you have some Java experience, you know Java, so that would be fairly straightforward, getting it into the actual code and running it. So this is the philosophy behind this project. So small increments. We're going to basically walk through 7 different iterations in this application. So it's going to be 7 different slides, basically. The app at any point must run. So even if it's not doing much, it must be whole and complete, basically. And we're going to refactor the app as we see fit. So we're not going to worry about boiling the ocean right up front, but we're going to fix things as they are not optimal anymore. And by the way, all this code is available for free, and it's also, the 7 iterations nicely match the chapters in a book if anybody cares about that. But the code is available on GitHub, and I'll tell you where to get it later on. So this is part 1. So what we have, just to kind of give you an idea what the boxes are. So this box, this is our application, basically represents our application context. Right? So that's the entire thing is our application. Think of it as a pizza dough, right? Now, inside of it, I'm going to use the main building blocks, those components that we just theoretically talked about, activities, services, providers, receivers, and some other stuff that goes along with that. So in this first iteration, what we do is we put together really quickly a piece of UI, a piece of GUI, right? So this would be an activity. And this activity has basically, well, I'll show you what it looks like. That was the activity that we looked at here. So this would be that activity. So it's pretty straightforward. It's got one big box where you can type something, right? And it's got one button, and you press that button, and it attempts to make a web service call out to the internet. And if it's successful, posts the message to the server, right? So what we do, so that's basically what we do in this iteration. So we create the UI, we make a web service call, and go outside to Twitter and post this message. Now, at the previous point, what we did is we hard-coded the username and password. In other words, it was working for a specific user. So it wasn't very useful to anyone else because they couldn't possibly enter the username and password. There was no way, there was no functionality for that. So what we do in the second iteration of this project is we add yet another activity. So yet another piece of UI where you can actually enter your username, password, and in my case a server as well because we're not using twitter.com, but in theory it could work with twitter.com as well. So this is new. What we also do is we use something called shared preferences to share this data because both of these guys need to know the username and password. This guy needs to read it, right? And this guy needs to edit it, essentially write to it. So they both need to know what the username and password is. So we share that via a file. Notice that this file, again, it's inside of our application. So it's private to our application. That's that concept of application sandboxing that I talked about. So at this point, we have an app that not only can post, but you can also change username and password, which is pretty useful. In the third iteration, what we do is we now add a service. The job of this service is to basically run in the background and periodically check Twitter for updates, basically to see if, what's going on. It sort of works like, you remember your POP3 email? So you set it and you say every 15 minutes go and log into my server and check for a new email, right? So that's sort of what it does. So it sits in the background, always on, always running, doing a periodic pull of statuses, i.e. tweets from Twitter. So basically it does that, pulls the data. Now in this iteration we can verify that we got the data just by printing it to a log, but it's not very useful to a user. The user doesn't have a way of seeing it, right? So this iteration it's whole and complete, but it's not much more usable to a user than the previous one. So what we also do is we realize, hey, both of this guy and this guy need a way to connect to this online service and do this remote web service calls, that sort of stuff. So as opposed to copy pasting the functionality from these two components, what we do is we use that application object to basically extract it. So I create a placeholder where I can put where I can hang off of some common functionality, some common business logic, right? In this case, it's the way to connect to Twitter, for instance. And I also move the ownership of shared preferences to this object because it's readily available to this guy and to this guy, so they have a way of getting to it, right? So that's the third iteration. The fourth iteration, we now have a way to actually, those tweets that we got here every 15 minutes or so, we have a way to save them in a database. So this would be my database, right? So that's why I save the data in this case. Now you still can't see it as a user, but we can verify the data is there. So we're building these pieces, although the functionality doesn't appear to a user yet. The fifth iteration, we finally build our final third screen. So this is the screen where you actually view what's going on. So that would be presumably one of the more important screens. That's where you're seeing what your friends are doing. So basically this screen is yet another activity, right? And it's pulling the data from the database, the local database. That the data was fed, remember, by this service, and the service was the one that was periodically connecting to Twitter. Now in this particular case, I could have done this as well. I could have done a direct connection from timeline activity to the Twitter service. And in that case, I would not need this, and I would not need this either, right? I could have done that sort of design. I chose not to. And the reason why I didn't want to do direct connectivity from the viewing activity, from the viewing piece of code to the server is a couple of things. For one, it would not work when we don't have the network. So it would be subject to a network, right? For example, I don't have a network connection right now, yet you can see you were able to see my tweets on the previous page, right? You can basically see what my friends are doing here, okay? Secondly, we would depend on the network latency. So in other words, to see what's going on, I would have to wait every single time for my friends. So instead of doing that, I basically chose a design where we are doing this periodic pull. We're saving stuff in a database so that it's instantly available, although it may not be the latest version. Yes?
Sorry to interrupt. I don't see on here who's coordinating which activity pops on the screen when.
So the question is who's coordinating when what pops up on the screen. So the user gets to basically enter the application at start time, and you designate one activity as a main entry point. So in my case, this was the main entry point at this iteration. So I declared a home page. Okay. From that point on, I actually have a little menu system. So it's just a piece of UI. So there's a little menu system here that allows you to click on, kind of like a navigation in a website. Okay, that's what it does. In itself, it's nothing special. It's just a piece of UI. But what is flip-flopping from one activity to another activity, back to this activity, and so on, are intents. So in other words, my buttons, my widgets, are simply firing off intents. And the system then says, okay, I got an intent to start preference activity. I'm going to go and start it. And then the system is also going to figure out, hey, is this something that was already started and it's sitting in a stopped mode, so we can just basically pull it from cache, or does it need to be started from scratch? So the system worries about that. And your code just basically responds to those lifecycle methods, basically. Yeah. So that's kind of how the user navigates through these screens. So at this point, we have an app with 3 pieces of screen. You can flip-flop between them. You can post data. You can get data. So it's pretty usable at this point. What we do in the 6th iteration is we want to add certain additional features. For example, this service that is responsible for pulling data from Twitter, I don't want to have to remember to start it as a user, right? If I power up my phone, how do I have to tell the user, hey, you have to go and click start the service, right? There is a button here, start a service, but it's kind of pointless to force users to click on it when they may have 4, 5, 10 different apps that need the same functionality, right? Think if you had to start your Facebook every single time you start your phone. So to get around that, I use broadcast receivers. So remember, broadcast receiver is a little piece of code that you subscribe to some kind of event, and then it does something. So in my case, the event is boot complete. So the system fires and it broadcasts an intent, and it says, hey, I'm finished booting. Who cares about that? So my piece of code says, I care about that, and it says, okay, the system is finished booting. I'm going to start up that service. So that way, my service is always on, always running, right? So that's a couple of lines of code when it's all said and done. Now, I have another receiver here that basically stops my service when there's no network connection, right? And then restarts it when the network connection comes back up. So for example, I jumped on a plane, I forgot to turn off my phone, not that it never happens, right? And I have this service that's always on, always running, trying to connect to the cloud every 15 minutes. They're different kind of cloud, right? So it's not going to be very successful at that. But in the meantime, it's going to be firing up my radio. And whenever you start a radio, your battery consumption goes up tenfold, right? So it's pretty expensive. So that's why by the time the plane lands, my battery is probably going to be drained up because it was unsuccessful in connecting to the net. So what I do in this case, I basically say, look, I care about network up and down, going up and down events. Intents, right? And when that happens, I do the opposite to the service. So network available, start a service. Network unavailable, stop the service. So that's basically what we do in this iteration. And finally, this is the final iteration. What we do in this iteration is basically make the data that we collected in this case, we make it available to right now it's inside of this box. It's only available to this one application. But what if I wanted the tweets to show on the home page, on the home screen, right? There's a little widget. You know how you have those little widgets on a home screen that show you different nuggets of information. So if I wanted something like that, I would need to actually expose the tweets to the outside world. So in this case, I want to put a Yamba widget on a home screen. But to get the data, I need to expose it via a content provider. Remember, that's insert, update, delete, and query, that interface. So that basically pierces that security hole and exposes the data to the outside world in that case. So it's sharing the data with another application. So that's basically the design of that app. So that app looks like this on a standard phone, version of a phone. I actually have even a version that I wrote for tablets, so for Honeycomb, right? So this would be the version that runs on the latest version of Android, 3.1, 3.2, and so on, right? So it's slightly different, different form factor. It actually, in this case, I'm connected to actual Twitter, so you can see the tweets here. The menu in this case is here, so I can do preferences. So this starts the preference screen. You can, or not, you can click on refresh. This would attempt to refresh my timeline. Again, it's probably going to be unsuccessful in terms of connectivity. But that's the same example as this one on a different screen. Okay? Yeah?
So you got two different kinds of, if you switch back to your structure, you got two kinds of apps. You got the big box app context, and you got the one that's labeled, the big one says application, and the small one says app. And you want to little bit more to reiterate what's the difference between those two different
So the question is about this one and the application context? Yeah, cool. So basically, the application context is a construct that refers to all the components that are part of your application. That would basically be that dough in a pizza that basically holds all your toppings inside of it. You have an access to that application context, and that access is this application object. So application object is essentially, it would be a Java object that represents that piece of code. But the context is more of a construct or a concept. So it's not really tangible, but if you want to sort of do something to it, you get the application version of that. Yeah.
Let's say the user uses your application once just to try it out, and that status provider in the bottom right there, or that status provider there, kicks in, and so now maybe the user might never use the app again, and still that status provider is going in the background all the time, trying to collect tweets and using the battery. Does the user have a way of saying, turn it off, I'm never going to use this again?
So the question is, I think it's more about the update service, right? So that's the piece of code that keeps on running. It's actually running, in my case, indefinitely, right, until somebody stops it. So what happens when the user never uses it again? Is it always on, always running? And that may be the case. That's why one of the complaints in the Android ecosystem is that the battery doesn't last long, right? You get the latest, greatest Evo or some other great phone, and it appears to run slower, and it's sluggish, and the battery keeps draining, and so on. So it's not the problem with the phone or the operating system. It's really the problem is with the apps and the bad apps, and especially in the app market, there's not a lot of enforcement around the applications, right? It's reactive control as opposed to proactive enforcement of applications. So yes, it's quite possible that you have a lot of applications that are cranking in the background and not being very useful. As a user, you do have a way to see what's going on, and that's by going into your menu, settings, and then you can go into applications, and you can go into running services, and you can actually see those services. So as a user, you could go and you could say, okay, there's some service open, WNN. I can click on that, and I can actually stop it. Right? So if I flip over to my Yamba app and I start my service, just to kind of show you. So if I do menu, start service, and if I flip over to that settings, if that service starts successfully, it would show here. There we go. So it shows right now that it's running. Yeah, I can basically, as a user, I can click on it and stop it. If the developer didn't provide for a proper stopping of that service. In this case, the service died itself just because it wasn't able to connect. But I could click on stop as well and stop it. Yeah, question?
Online, there seems to be a lot of debate about app killers for the Android. Some people think they're great, and some think they're actually make the performance worse. Could you talk a little bit about why there's a debate?
So the question is about the app killer debate. Are they useful? Are they not? What I think about it. So it is true. A lot of people, one of the first apps they download is the advanced task killer. You don't need an app. You, as a user, like I said, you have through your settings. You can go here. You can click on Manage Applications, and you can see all the running applications, and you could go kill it from here as well. The problem is that this is way too many clicks far away from a user, right? So you have to click, click, click to get to that UI. So those applications just make something that's already available a little more user-friendly. So that's usefulness of it, of those applications. Why we even have those applications? The problem is that we have basically a lot of applications that are not that good. So in an ecosystem like Apple's App Store, apps are more controlled, right? So the quality of the applications that make it tends to be a little higher. Whereas in Android, a lot of things just kind of go in, and some of those apps end up wasting your resources, your battery, and such. So just the difference in the ecosystem, and that's probably one of the big problems in the Android ecosystem right now. Yeah.
some general questions about Android. First of all, the versions that are coming and the control of the versions.
The physical?
Like how often there will be, because my understanding there's so many, like too many versions and they're not.
Too many versions of the Android.
Yes. And the other thing about tablet, using Android on tablet.
Yeah. So the question is, what about versions of Android? I would imagine you're hinting at fragmentation, because that's one of the topics that people sometimes bring up. I'm not sure why the screen is disappearing, basically, Android is built in such a way that if from the get-go the goal was that you're going to have a same operating system running on many different devices, and you're going to have many different vendors innovating on top of that, right? So HTC has their Sense UI, Motorola has Moto Blur, Samsung has TouchWiz. Every single company innovates on top of Android. That's a great thing, right? I think fostering innovation at that level is fantastic. The problem is when applications don't run on different devices, right? That's the real problem of fragmentation. Think Unix, for example, or Linux versions, right? So apps don't run, you have to recompile them, yada yada. So that would be really bad for a consumer. Now, the way that Open Handset Alliance or Google addresses that is by basically creating something called the Compatibility Test Suite, CTS. So CTS is a set of tools that they enforce on people that they work with inside of the Alliance, and basically say, look, if you're going to be an Android device, you got to adhere to these standards. And it's a document that basically spells out the capabilities of a device, what it should or should not have, or what it must have. And it's also a battery of tests. So, Samsung releasing the latest version of a device can run the battery of tests and say, yeah, we're good to go or not. So that's kind of how that is a potential problem, but there's also a tool to kind of enforce certain rules in place. So. Android in tablets. So Android in tablets is just another version of Android, namely Honeycomb. And that's what you're seeing right now. So, if I go to home screen, you can, well, you're not seeing my screen. I'm not sure if it's on my end or not. But Android in tablets is basically just another version of Android. It's a little unique because it's not open source. So the source for it is not available for various reasons. And it's a big departure from standard Android just in terms of UI, right? And also how it's different is that currently it's a fork in the source tree that we have, and we're supposed to put it back together in sometime in October, November, when Ice Cream Sandwich comes out, which is the next version of the system. Yeah. Oh, so it was the Mac. Thank you. So that's a little bit about tablets. So each version, each release of Android has its own sort of unique capabilities and unique changes. So Honeycomb, which is the current latest version, the big deal is that the UI is totally revamped to basically look good on a tablet. So that's what you saw in my Yamba application, for example. The menu that used to be in the previous case, the menu used to be the bottom, for instance. It used to be here. Now it's, for example, here. We have also certain features like we don't have buttons, so there are no physical buttons. So for that reason, we must have, for example, a soft version of a home button available everywhere, the soft version of a back button available everywhere, and so on. So there are certain UI sort of changes that are substantial, among other things, but that's the big one. So, and yeah.
Two questions. One, can you talk about
I'm sorry, we're just doing Q&A at this point? So we can bring microphones to people.
Yeah, well, yeah, we're doing Q&A, I believe. That's how the timing works, right?
I wasn't sure if you still had it.
Got it. Yeah, I'll be happy to do Q&A, and I can repeat the questions as well. So.
Well, and we appreciate you repeating the questions.
Okay, cool.
Two questions. One, can you talk about non-Java development, like the scripting layer for Android? And the other question was, when it comes to user interface design, does the programmer have to deal with different resolutions, or can Android relay out the screen automatically?
So let me, to answer the first question about the Java in Android. So let me just pull up a slide, because that's the easiest way usually to talk about this. So basically, now, since you guys are Java guys, so in standard Java, what happens is you write a Java code, you compile it using Java C, you get bytecode, and then you run that on top of Java virtual machine, right? In Android, it doesn't work that way. So we still write the very same Java code, right? We still compile it using the very same Java compiler, so the same tools, right? We get the same bytecode. But then these steps are sort of different. What we do is we recompile that code once again using something called DEX compiler, which is basically creates a new bytecode that runs on a new virtual machine, in this case, something called Dalvik virtual machine. So it's a replacement for Java virtual machine. So in other words, there's no Java VM on Android device anywhere, right? And so that code runs on top of Dalvik. So that's what happens, and that's how it works. And this may look like an extra step, but it just happens magically behind the scenes, and you do not need to worry about any of this stuff, right? It just happens. Now, a lot of people are talking about writing Android apps in alternative languages, right? Namely Python, Ruby, Scala, and those are some popular sort of languages. So basically, any language that will compile down to your Java bytecode, you can now recompile once again using Dalvik and run it on top of the Dalvik virtual machine. So it's still going to run on Dalvik. It's still going to be based on Java bytecode and Dalvik bytecode subsequently, and that's how that happens. So there's some work that even Google is doing with Go language, sort of a very simple. I don't know if you guys are familiar with it, but it's basically, think of it as the BASIC of the 90s, right? So it's a very, very simple programming language. So that's used for programming for Android as well, or could be used for programming for Android. So, but basically compiles down to Dalvik. Yeah.
The other question was about user interface relayout for different screen sizes.
UI relayout for different screen sizes. So in terms of that, let me just kind of, again, the UI in Android, let me see if I have the appropriate picture. So the UI in Android is very similar to the UI in Java, right? So basically, you have the container component model. Are you guys familiar with Swing or AWT? Most of you, right? So it's a very similar concept. So we have containers and we have components. We just call them layouts and widgets or views. So we don't have separate layouts like we do in Java. Now, in terms of the various screen sizes, what you do is you basically specify, you can hard-code the width and height of your widgets. You can say, I want a widget that's got, my button is going to be 23 pixels or 15 pixels or something like that. Or you can use a more of a sort of quasi-terms. You can say, I want my button to stretch and fill the entire screen, or just wrap its own content. So by using those sort of soft declarations for width and height, your UI should automatically adjust for any size, so it should, any device. So it should be agnostic to the actual screen size, right? So it doesn't matter if my Yamba application, if I deploy this application, where is it? If I deploy it on a tiny little phone, or if I deploy it on a Google TV, it should look good. Just to kind of illustrate this, right now I have it in a portrait mode, right? But if I flip the screen if I rotate my device, so let's see if that's going to rotate. If I rotate it like that, notice that it resized properly. Right, so you know it wasn't, this blue box didn't stay like this, but it rather sort of filled in the entire space available. So it resized properly regardless of the size of a screen. Okay, so that's an example of that. It all change depending on the screen, and the same thing applies to the screen size. Now, developers are often sometimes lazy and would hard code things, right? So think of it as in a web development. If you use Dreamweaver to whip together a web page, and you assume a certain, 800 by 600, for example, resolution, then everything's going to get stuck to that resolution. So it doesn't matter if I'm viewing on a larger, a small laptop or a large monitor, it's going to look small. So the problem is the same. It's just that it's a little more even obvious on a mobile device because the screen sizes are, order of magnitude bigger, sort of. So, yeah. Questions? Yeah.
Let's do the microphone.
But you're using it, it's not working, that's okay.
So what's the tool you're using to draw on the screen?
Oh, what's the tool that the tool that I'm using for drawing on a screen is called OmniDazzle, and it's a free tool that comes from Omni Group, omnigroup.com. Yeah, that's it, OmniDazzle. So, yeah. I just use my finger on a trackpad, yeah. So yeah, so that's that. By the way, the source code, the code for this versions of Yamba, it's all available on this GitHub address. Some demo code is also available there. I have a version of slides available here, so you're gonna be able to basically get to this if you didn't get it. And actually, this shortener is probably all you need because it's got a lot of links to the original content, so you can basically get it from there in case you care about it. Yeah. The question is, do I have any iPhone experiences? As a developer, not really. I have Objective-C experience a lot, but not iPhone, iOS. So basically, the question is about the iPhone developers switching over to Android or jumping onto Android platform. So from user standpoint or developer standpoint? Both. I think from the user standpoint, that's pretty straightforward. I don't really have a lot of comments on that. But from developer standpoint, it tends to be a totally different experience. I've trained quite a few people who were iPhone developers and decided, started doing some Android work. And basically, it's a totally different, paradigms are different, programming language is different. So there's not a lot in common. In that case. But what's happening a lot is people are starting to develop applications not natively, but using HTML, CSS, JavaScript, basically web technologies, and then deploying them using something called WebKit. So WebKit is sort of a standard, the common denominator between iPhone, Android, BlackBerry, WebOS, and so on and so on. So they all use that little component. And 70–80% of applications out there you could successfully write in HTML, right? There are frameworks emerging in this space that are making that job easier. And these frameworks actually are pretty elegant. They would take your HTML application and they would wrap it with a native layer. So the user actually never knows it's an HTML application or a web application. It's not like a user is going and opening up Safari web browser or something like that, but it's rather runs as a native application. So there's something called Titanium by Accelerator. That's a big one. PhoneGap.com is another one. So those two are pretty good and pretty popular. There's a third one called Corona SDK, which is more sort of angled toward games and game developers. So it's good for graphics and stuff. But these three are the three that I know of that are sort of getting a lot of following, and a lot of people are doing a lot of interesting things with that. And when you take that in conjunction with HTML5, which is pretty powerful, JavaScript and jQuery mobile specifically, and CSS3, you actually have a set of tools that is quite powerful for developing most common web or mobile applications. So that's definitely emerging as an alternative. Yeah, question?
Is there a fundamental difference between, let's say, a Samsung Droid app, apps that you cannot remove versus apps that you can remove? Is there a fundamental difference between those apps, or is it up to the, I guess, the operating system?
Is there a fundamental difference between the apps that you can or cannot remove? Let me just really quickly pull up a slide just to kind of show you the file system that we have on Android. So on Android, we basically have a file system that looks like, it looks like this. So there are essentially three main mount points that we have. Let me put it like this. So we have a data mount point. This is where user data, anything that the user saves, downloads, installs, that sort of stuff, you have contacts, all that stuff is in this partition, right? Then we have a system partition. This is the operating system. Like if it was Windows, this would be C:\Windows. Now, on every single Android device, this is mounted read-only. In other words, you cannot change anything. Whatever is there is written in stone, pretty much, right? So the system apps, the apps that are preloaded on your Samsung device or your HTC device that you get from your typical carrier, are installed in this folder here, apps. So in other words, they're written in stone, right? So they're shipped to the phone. My typical example I use is if you get Sprint Evo, it comes with a NASCAR application. You may not care about this NASCAR application, but it's going to be there forever. There's a term for those apps. They're called bloatware, right? So and that it's kind of like in the PC industry, you get your Dell and it's loaded up with a bunch of stuff you're never going to care about. So that's a problem, right? User applications, the one you download yourself, end up being stored on this partition, and you can freely uninstall them, delete them, and so on, right? So that's the difference between those two places where apps get installed. And you as a user don't really know that until you, unless you go into an application, you try to uninstall it. If it's grayed out, then it's a system app, and you're not allowed to. You can't. Yeah, another question?
How do you handle security of user data?
How do you handle security of user data? That's a big question that there are a lot of answers to that. There are encryption tool, basically there's encrypting the data on the device itself. There's encrypting the point-to-point between the user and the enterprise, for example. And so on. I can give you sort of a quick overview of what Google is claiming to be doing in terms of security. I may not have it actually on this slide deck, but Google is doing a bunch of things in terms of trying to secure those things, but not everything is actually, it's not quite there yet. So let me show you this. Hold on a second. So I mentioned sandboxing. So basically, each application in itself is going to have its own sandbox. This is managed down on the level of Linux. So it's quite secure. We know a lot about Linux, right? So each app is its own process with its own UID, user ID, on Linux user ID, and so on. Remember, this is that pizza dough, right? And we have any number of activities, services, receivers, providers, and so on, right? But they're all inside of that box, inside of that application. But we also have files, database files. We also have files in a file system, like where I'm storing my username and password, for instance, and so on. So it's inside that box. So no other app can actually view it, right? So in that case, it's secure. But then what happens if somebody rips apart your phone and actually takes out the hard drive or the flash drive and connects it to another device and reads like sector by sector? That's where some other interesting concerns come up, right? Such as encryption. So certain things are managed quite well. Certain things are missing pieces. But the plumbing for Android in terms of security is very solid. It's just that we need a lot of things to build on top of it to actually take advantage of it, like BlackBerry has done, or even on weaker foundations. So that's something to do for Android. Yeah.
If I understand you correctly, each application is a process under Linux.
Yeah.
So can you talk a little bit about how the different entities are allocated to threads and how they get distributed between the threads, the physical threads, the VM threads, and all of that?
I have a picture for that. I can give you a quick overview of something like that. What happens? There's inside of an app. So I mentioned that inside of an application, everything runs on one thread. Let me show you this picture. So this is what typical application looks like, right? So it's a Linux process, right? And typically, inside of an application, you have any number of those main building blocks we talked about: activities, services, providers, receivers, yada, yada, right? Now, things happen, right? So user clicks on a button, user scrolls, phone call comes in, things happen, right? So those things get registered on the back of a queue. So there's an internal queue that basically just kind of keeps track of these messages. So it's, a message here goes here, another message goes here, another message goes here. So it just kind of queues up, right? Now, there's a single process called a looper. So a looper simply goes and takes one message at a time, says, okay, what's my next job? And then does it. Goes, okay, what's my next job? And does it. And it delegates to, for example, an activity, to a service, and so on, right? So this guy works serially. So in other words, if this guy is working on a big time-consuming project, this is going to get blocked, right? So let's imagine this is blocked. We're trying to, remember how I pressed on a button to post to Twitter, right? Well, I may not have a network connection. That means that this guy is going to be blocked here, attempting to post for up to 30 seconds until the network says, I give up, right? Well, in those 30 seconds, nothing else is going to be responding. The UI is going to get totally stuck. Well, that's not a very good user experience. But since the entire Android system is running your code, it's not you running your code, it's the system running your code. It says, okay, you know what? If this is taking too long, and the too long in activities is defined as 5 seconds, it basically pops up that message that says, would you like me to wait or force close? You know the dialogue, I'm sure you've seen it multiple times. That's called the application not responding, or ANR. There's even the short form for that because it's so common. So that's what you try to avoid. And the way to avoid that is to basically, if it's a long-running task, you may outsource it to another thread that you may create yourself. And that thread would then be responsible for making updates and so on. And then there's some useful auxiliary classes. You can use all the threading you have in Java, but there's certain things that are specific to Android, like updating a UI from a non-UI thread. And there's some tools for that, such as async task and so on. So there's some helper things to help you with that.
And are those threads like physical threads or VM threads you're talking about?
So these are physical. They run inside of a virtual machine. So everything here I'm talking about would be inside of a virtual machine. Ultimately, when you're writing an application, you're constrained to running on top of Dalvik. Now you may have native code, but that like a native library that you load up using JNI, but that native library is still subject to Dalvik execution. So it still runs on top of Dalvik virtual machine, right? So if you look at this picture, right? So the Dalvik would be here. So blue is Java. So all these classes are running on top of Dalvik. But so is if you have a native library, it gets loaded by Dalvik and runs on top of that. And that sits on top of a Linux process.
If you develop in C++, is the same issue?
Well, so if you're developing applications, yes, you can develop bits and pieces in C++. But those bits and pieces are loaded via JNI inside of Java, or Dalvik specifically, yes. Now, if you're writing pieces of the platform, so you're not constrained to an application, which is not what we're talking about, but if you're running bits, then you can write any piece of code and just pop it to the platform and run it. But an application, it's always going to run, it'll be constrained by that sandbox in Dalvik. Yeah. Any other questions? Let's
have just one last question.
Okay, there was...
and then hopefully Marko will stay around for additional questions.
No.
I was wondering if Android provides any smart management access. So let's say access to find out if you've only got one signal bar, maybe you could intelligently not access the web, or if you notice you're running low on battery power, you automatically turn things off?
Yeah. So the question is there a smart management so that if you know that the system is running low on power or it doesn't have a lot of connectivity, what do you do in that case? And the answer is yes, and it comes back to the main building blocks, right? So broadcast receiver is a piece of code where you say, I care about something. So you can say, look, I care about battery running below 25%. Or I care about network disappearing. And then your piece of code is going to get notified when that something happens. So you do have a simple publish, subscribe, and publish, subscribe mechanism to get notified when things that you care about happen. So that would be one thing. Another thing that we also talked about, so if I do know that network is running unavailable, I do have the system services. In this case, it would be, for example, the connectivity service. And I can say, okay, now I want to tap into the service and say, hey, can you tell me what kind of network are we on? Can I flip-flop between Wi-Fi, Bluetooth, mobile, 3G, and 4G, blah, 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 and so on. So you do have these services available to you to tap into. So using these building blocks, these Lego blocks, you can assemble any application of that type. So yeah. Cool. Any other? I guess that would be it. So, like I said, I'll be around for a little while, and all these artifacts are available here, and I'm also recording everything, so it's going to be available later on as well. But yeah, thank you guys, appreciate it.